Right, today we are going to be talking about finding intercepts, the x-intercept and the y-intercept. We're going to do two different methods. First off, we're going to talk about finding it from a graph, which is super easy to do because it's visual. There's no math involved. So to find the x-intercept from a graph, what you're doing is just looking for the place where the line crosses the x-axis. So you'd have to know that that's the x-axis, and where does the line cross it? And it looks to me like it's crossing at x equals 2, or if you wrote it in an ordered pair form, x is 2, y is 0 at that spot. Then for the y-intercept, which is the place where the graph crosses the y-axis, you'd again have to know that that's the y-axis. And then you're looking for the place where the graph crosses it, which would be right here. And you could say that that's at y equals positive 1, or you could write it as an ordered pair, 0, 1. So again, that's how you're going to find intercepts from a graph. All right. The second thing we're going to be doing today is finding intercepts from equation. This requires a little bit more work, but nothing crazy. So the idea, and maybe you noticed it on the first one over here, there was a pattern involved, and that pattern has to do with this number right here. It happened in both answers. We had a 0. All right. Now the reason we get that 0 is for the x-intercept. For something to stay on this x-axis that's right here. So for something to stay on that x-axis, when you start at the origin, you're starting here, that means you may move to the right or to the left as much as you would like. But do not go up or down. As soon as I move right and then up, I'm off the axis anymore, so that's not what I want. So the up and down number would have to be 0 for have an x-intercept, because that's everything that stays on that line. The opposite is true for the y-intercept. For something to stay on this y-axis line right here, considering you start at the origin in the center, would mean that you may move up or down as much as you'd like, but just don't go left or right. If you move left or right, you're no longer on the y-axis. And the left and right number is x, the number for don't go anywhere is 0. So that's why we have those zeros there. And that's what we're going to use to find intercepts from an equation. To find the x-intercept, we simply take the y part out of the equation by making it 0. And then solve the leftovers for x. To find the y-intercept, we're going to take the x, make it a 0, which essentially eliminates the x term from the problem, and solve for y. If you had me for algebra, I called this the cover-up method. It's not an official name, it's just what I called this. So here's how it works. So if I have an equation like this first one here that's in standard form, and I am looking to find the x-intercept first, so to find the x-intercept, essentially what I'm going to do is I'm going to take this y term right here and turn it into a 0. Because negative 5 times 0 would be 0. And I don't need that term. It's kind of like throwing it away. It's why I call it the cover-up method. So essentially to find the x-intercept, throw the y term away, solve everything else. So we have to divide both sides by 4, and we would get an x-intercept of 2.5, or 2 1/2. Now, to find that y-intercept from the same equation, we take the x term and essentially throw it away, leaving just negative 5y equals to 10. So we'll divide both sides by negative 5, and we will find out that the y-intercept is going to happen at negative 2. If you're writing those as ordered pairs, that'd be 2.5, 0, and 0, negative 2. If it's in slope-intercept form, same thing happens. We're going to find the x-intercept first. So to find the x-intercept, we take the y term and make it a 0, throwing it away. So let's do that. That would be 0 equals 3x minus 5. There's a little bit of work involved here. I'd have to add 5 on both sides. I get 3x equals 5, and I'd be dividing both sides by 3. And I'm going to get an x-intercept in decimal form at essentially 1.6 repeating, or in fraction form 1 2/3. So there's my x-intercept at 1.6, 0. Then to find the y-intercept, again, I take the x term, the opposite term, throw it away, making it a 0, which would just leave y equals negative 5. Oh, well, that's why we use the y-intercept so much in slope-intercept form. I think I didn't require any work to find it. That's what makes it so nice. Whereas the x-intercept required a little bit more work. But the y-intercept, it was just this number right here staring us in the face the whole time. That's why that formula is so convenient. All right, so 2 jobs today. Your job is to find the intercepts from a graph and to find the intercepts from an equation. All right, good luck.